Oh, excuse me. Hello, it's Damon. Crazy Logics 007 on YouTube and Crazy Logics most other places. We're back on this Rockford. I'm actually going to set it out of the way because we're working on these. Let's see if I can get this to focus on there. Just want to focus on everything but. Let's grab the little camera, maybe here. And not the easiest thing in the world to do. Let's go big screen here, see if we can get to focus. There we go. So you can see I've wrapped a couple of these already. I can hold it steady and it'll stay focused. And made some pins. And we're going to do the last one here. So I've got my wire. And this may have, I may start and stop this recording, so it may have some transitions, but I'm just going to bend it around and get it bent pretty flat and tight. So I can slip it underneath here, turn it, and bring it back. And that looks pretty good, but it wasn't super tight, so I want to get it a little tighter. Just a skosh. Just a smidge there. I want it to kind of have to work its way on there. I may have got it too tight. Back it off just a little so it can get on there. Yeah, fit with a little tightness there. I'm going to go ahead and bring it up with a nice bend. Bend it back this way. Get my smaller pair. Give that a little crimp. Work this over. And then we're going to put a little bend in here and just flatten that down and work that into where that pin would be. Hopefully you can see that. Then we'll snip it off at the approximate height. It can be a little long, that's always fine. Fire up the soldering iron here. We're going to look and make sure, and we're going to put solder there. Now, like I said, this wrap makes it so that when we solder this thing up, while it's in the board, this does not come free. You know, even if the solder gets totally liquid again, it's wrapped around the part that broke, and so it's gonna, you know, it'll just re-solidify on there. Plus, we've kind of got that crimped on there. You can give it a little squeeze with your pliers to make sure it's good and tight. But we got a good copper to that gold-plated copper setup there. I've glued this piece back on, and we're just going to come in here with a little bit of solder. Always clean the soldering iron off. Get it in there, and I need my magnifying cheaters here. Yep, we got a nice good soldering joint. Ooh, that's warm. So we avoid this section for a second. I have an old RCA jack that kind of came apart, but it's got a good end, and it lets me do measurements and stuff. But I always take it, and you can see that the RCA has not got to the shield yet. You want there to be resistance when you start to push that on there. That means that the inner tabs, there's a little resistance there, but you want to stop that so that there's resistance, and if there's not, that is good. If there's not, depending on the style of RCA, you can get in there with a pick sometimes, and flick them a little bit, kind of give them a little tweak. On this style, you can actually get a hold of it with pliers real nice and actually pull this whole thing out and then give it a little squeeze and then reinstall it down in there. But when you if you've ever seen online, if you're in some of the groups where some repair technicians have showed off what they've done, and maybe they listed because an amp's for sale, it's a personal amp that they're trying to sell, or one that the customer did not pay for, and they're needing to move it because they got money in it. But they'll talk about reconditioning the pots and the switches and stuff. That's normally with deoxit. Sometimes they do have to replace them. I know a lot of older sound streams just need them replaced because even though it's a quality amp, the switches and stuff that they chose did not hold up over time. But I was a little suspect of this one. This one's pretty beat up, so I wanted to test all them. But if they say they've reconditioned all the RCAs and stuff, they went through and made sure they're clean on the outside. You can take a little Scotch-Brite and kind of make sure that's clean. And then they've tested each one of these with one of their own testers. And if they're not got that good tension to it that makes sure it's getting good connection, they'll either pull these pieces out or they'll tweak those in until they get a good connection there, and that way you got a good solid RCA jack. So we look like we're all fixed here. I'm gonna bend this into a little better alignment and make sure this one's here. These are staggered where this is the closest to this way, then this, and then this is the furthest back if you look at the board. But there's our 3 legs that broke off, and now we have rebuilt this. I need straightened a little that way, and that should go into the board fairly easy. We've tested that. I cleaned it up a little bit. I noticed there was spray paint kind of on here. That this amp's had somebody's shot a little paint around it or on it to make it look cleaned up. This has been super glued. If it doesn't hold up going back in there, we'll put a little E6000 on there to give it a little additional support. Because all that holds these in is these legs and then the 2 screws on the cover. So it'll hold itself in position pretty good, but I like going ahead and making sure there's a little good connection to the board. So we've done that. So that's prepped and kind of ready to go in. Treat for the puppy dog. I'll put her on puppy cam here in a minute or something. She's not really a puppy dog anymore, but she's still my pup. So we did this. We put these FETs in, but we haven't soldered them. We was going to attach this to the board, but I dang near forgot. When FETs die, there's driver circuitry. There's going to be this, and this. That's the transistor driving it. Goes through these gate resistors. Here, there, and there. And I noticed something when I was looking on this board, because I thought of that, and I thought, oh, I need to cover that. I wrote that in a little to-do list here. I noticed a whole bunch of these resistors. I'm gonna grab the other cam so you can see it. But if you look, let's get above it here. This is labeled R5 or 154, so 154. But the resistor, you can't see the writing on it. They've installed the resistors upside down, which is not very good quality control. That probably would not fly nowadays at Rockford. I think this was back when it was still made in the USA. This one is, maybe not. I know all of Rockford's stuff's still designed in the USA, but they have overseas manufacturers now to keep labor costs down, just like everybody else. It's kind of a sad deal. But a ton of these resistors are flipped over and you can't read them. So fortunately, these sides are basically mirrored, so you can see what it is. And all these gate resistors, the resistors that are on the gate leg, are all labeled 100, which is a 10 ohm resistor. So this should be a 10 ohm resistor, and so should that one. And so we can test that. We can check those. So we get our meter on, and you can see that, yes. And we go in here and we touch. And we got 10.10, or 10.1, sorry. And then this one, I'm not getting a reading there. That's not good. And then we got this one. That one reads 10.2, that's pretty good. And then this one, I'm not getting a reading on that. So the two that were driving the 9540s are not getting a reading. So that should go to this driver trans. Oh, let's turn on the continuity so we can trace these. So this leg of the should run to that driver transistor. That one runs to that one. And this, I'm on the other side of the resistor here, should run, oh, and it's got a straight line to it, so yep. And then this one should come over to this little driver transistor. So I've kind of pre-looked at this because Rockford's drive circuitry for their FETs, because it's a MOSFET amplifier, is super complicated. Got all kinds of extra really cool things. You know, if you see Rockford, they talk about their trans-ana stuff and the punch equalization and all this other stuff they got in. And some of that's up here in the input side where the RCAs come in and through the opti-amp setups, and some of it's feedbacks and monitoring for all the output sides so that the circuitry works in a certain way. And so Rockford can be super careful. They got tons of these little transistors and diodes. A lot of these, if they're labeled D, like this is D100, that's actually a diode. And even though it's got 3 legs, only 2 of them may be used. So running off these gates, they run to the drive, and then they run over to the drive transistor, which happens to be these. And then they also run back, and then like this one runs back to this diode back here, and I can see on the pads it's only using 2 of them. So we're still in diode mode. So if you put your diode in one way, you should get nothing. It shouldn't conduct. And you put it in the other way, and yep, we got a diode reading. A 662 is a good diode reading. So that seems okay. We can kind of stick our, depending on whether this is a PNP or an MPN, boy, you just probably got a big old head full of bald head. There's a diode reading. And switch it around here. And there's a diode reading. So actually, even though this drive resistor, I couldn't get a good reading off of it, this FET's got, or not, sorry, this is not a FET, this transistor, that drives this FET, actually checks like a pair of diodes in here, which is what a transistor will normally check as. If it's good, you know, we were looking for a short, and so to see if it killed it, and that looks good. And I can get my probes on there. That looks pretty good. So thankfully Rockford's got good protection circuitry, and they use extra clamping stuff for the pull downs and stuff on these FETs. So you can test that, and you know, these two may have just died. They may have killed those resistors, you know, because they are small and tiny, and these transistors that are driving it may have survived just fine because of the extra clamping circuitry and stuff that that Rockford uses. I have seen in one of the newer Rockford amps, it blow out not only the emitter resistor, but the whole drive circuit way back and everything in it, and it had current sense resistors, a couple big ones of those on it and stuff, and I had to replace all of it and follow it all back. But I would think that since these are testing like a transistor would in the board as a diode, a double set of diodes. If I can get my probes up in there. And there is one of the problems of, and I'm going to get my head in the way here if I'm not careful. This is on the one that had I may have it backwards because PNP and NPN. So there we go, and then that should be, stick this one over on the side. Yeah, okay. So I got a funny feeling those survived and maybe we just got two bad resistors. So I'm gonna get my solder and stuff out here. And let's see, we said this one was bad, so I'm gonna get a little solder on it on each side. And then I'm just gonna kind of go back and forth, back and forth. Instead of getting the hot air rework station out, just gonna get it off there. And that one's labeled 100. And then we said this one on the other 96 was a little bit, I wasn't getting a reading on. So add a little solder to each side. And then just kind of go back and forth and get the slide off there. Get a hold of it with my tweezers and grab that last little bit. And if I flip that one over, it says 100 on it also. So we can try with the meter in ohms. Now that we've got them out of the board, we can try to see if we can get a measurement. Not the easiest thing to do on these little suckers because they like to go flipping out into space. That one don't seem to be wanting to read. And that one doesn't seem to be wanting to read. So I'm going to assume those died in it. I mean, that's tiny little components. And I've got some 10 ohm surface mount resistors. Let's see, are they all the same size? Yes, they are. So what I'm going to do, I'll get a little of my solder wick. And the secret for just putting in a little surface mount resistor is pretty easy. Get where you can see, get your cheater glasses if you're getting older like me, but we're just going to clean up the solder pads, get the excess solder off. Make sure they're nice and clean. Puppy treat. And then we will get out a resistor. And these resistors are labeled 10R0, which is still a 10 ohm. I'll show you. That'll be appropriate of me to do. And so that reads about a 10.2. And so I'm just going to take this and set it where that other one was. I'm going to get my soldering iron. I'm going to get a little dab of solder on it. Really get it cleaned up here. A little dab of solder. Kind of use my tweezers. Make sure you kind of, well, you're not really getting to see this very, very well, are you? I have so bad, that's why I want that third camera hook set up so I can somehow get a kind of a microscope zoom that I can swing over the board. But I'm going to hold it in place and gently with my tweezers. You're probably not going to be able to see this for a worth a darn. I'm sorry, I don't have the awesome magnifying equipment that you can solder under like some of the pros do that have a camera set up. We're just going to add a little solder, let it set up, try to make sure it's in the right spot, and then we'll add a little dab on the other side. Just do it one side at a time. Clean up your soldering iron and let that solder flow down into the bottom there. You can also do it where you add a tiny drop on one pad only of the tube, and that'll be your anchor pad. Sometimes this works a little better. Go ahead and get your resistor in there. Well, you have monstrous trouble seeing anything I'm doing. I'll try to get us a little better zoom in here. One of these days I'll have one of those fancy ones and can show it. Maybe. It's my goal. I'd love to have a little better equipment. Yes, Ellie, I hear you, babe. I know you like another treat. go on ahead and heat that up. Get that in there. Oh. And then we add a little solder on this other side and get the flow nice. And you know you've got it when you can heat one side and push and it doesn't move. And it's all in there real good. And then we're going to check with the multimeter, of course. Let's see here. Really? Puppy cam. There's the puppy. There's your treat. She's my electronics dog. She actually is the one that knows how to fix all this stuff. She just whispers in my ear to make sure that I'm doing it right. So now we'll put it on here and we will measure from actually the pad that it's going to the transistor. And yep, that means we had that whole circuit all the way through, and we'll go to this transistor and to this pad. And yep, we're looking good there. Now I noticed something I'm going to have to fix here. Where is my desolder braid? I got a little piece of it here. I got a little solder on this leg, and this is the one that we want free floating. So that we can mount that down in there. So that was an oopsies, but that's why you got to pay attention. There we go. And that'll end up being the one we're going ahead and solder down probably anyway, but a little more in here. Get that solder all sucked out of there. There we go. Alright, so now our legs are free floating. Now we replaced those two. I actually replaced them. Those were probably 1/8 watt resistors, and I probably put 1/4 watts there. Nothing wrong with going up in wattage a little. They don't fit perfectly, but you make sure your solder flows onto the pads. So those were probably what would that be, 08, 06s, and I probably put 1206 if you're looking for size. I'm not perfectly fluent in remembering all the size nomenclature. I normally have to get out my calipers and look at a cheat sheet, so don't think I'm awesome at knowing everything right off the top of my head. I don't. I have printed out cheat sheets and stuff to help me size things when I go to order them and stuff. So, well, that's got those two fixed. I think that should fix the drive circuitry. I'm pretty confident that those were okay. If not, we'll find out. And remember, I was trying to take the old ones out to maybe give me some test ones that were good, you know, a couple of them that didn't die. And that's kind of partly the rhyme or reason that I go for on salvaging old ones that I'm not going to use permanently in the amp. I'm not going to, it's not going to send it out to my buddy saying, oh, hey, here it's fixed, with used FETs in it. That could have taken a hit. It's not that they don't work. It's that they've already taken, they've already been in a damaged circuit, and so they've. I'll show you what I'm doing here. I'm just cleaning this all up over here, making this look better. Getting rid of the last of that old thermal paste that was all grimy, and cleaning up around these FETs some. This thing was kind of dirty, but having some that work that you don't mind blowing up, that's a handy feature. You know, especially when you're not a expert tech like me, when you're a do-it-yourself kind of guy, when you're into it as a hobby and don't have schematics for all this necessarily or anything like that, and you know, haven't been doing it for a living, you're going to make mistakes and you're going to not have something checked and you're going to pop some FETs. And it's kind of nice if you went through, and like now would be a nice time for me to have just tacked in some FETs instead of having these new ones in, and tested that circuit, you know, real quickly to make sure it was working, to make sure that these weren't damaged. But now we're risking new FETs, so it's a risk we're going to have to take. We're going to go ahead and see if I can get this to wiggle into place. Gotta make sure all the holes are lined up, and I need to do a little tweaking with the ones I've made. When you repair the legs, you might have to get them to line up real good. That side started to go in. I need to look, make sure all my holes are truly clear. Yep, they'll look good. And everything just takes time. Time and patience. And once you get them kind of in there, then they kind of wiggle down a lot better. And I'm going to have to push this in place a little. Just get this thing slowly but surely wiggle flat. Want a little treat, Ellie? Good girl. She likes hanging out with me because I give her treats. If it wasn't for treats, she'd probably say I was a stinky old guy. Oh. She's a good pupper, though. All right. Just about got this all wiggled in. Just take your time, get them all to wiggle down into place and get level and get seated. And what do you know, that piece I glued, it stayed on. This one needs pushed down a little bit. It's got a little bendy bend to it. And you just work it in there. We're already at 27 minutes. We're definitely going to be another video after this. I'm sorry. I don't want to make them too long. Man, hours worth of work of stuff, but I really like showing a big majority of what I do, so that, you know, if there's something that helps everybody. Now on these, I'm going to heat the leg and then let my soldering iron drop down to, but once the solder is actually melting on the leg, then add solder to the base. So start up kind of high, get the solder melting, and then just add a good thing where you get solder. So I'm going to shut up here while I'm soldering. I don't have my vent fan on. We're almost into summer. It's spring here, and we're going to be, or not summer, but we're almost into warm spring. And I'll be able to set up my big box fan now. I won't be able to run it while recording probably. It'll probably make too much noise. But when I have to build on a big amp where I have to solder in a whole bunch of FETs that blew up or something like that, because I've done some big 4,000 watters and stuff like that, it's nice to have my big fan flowing through there and just blowing everything out of the way and keeping me cool when it's warm. So we look a little more square, and that's a little more solid. I'm going to go ahead and make sure, we just could use the original. I'm going to make sure my legs are a little bit shorter than the factory legs, just so we don't get nothing touching. So I'm going to look at my little cheat sheet of stuff I got to do. I always write stuff down, like on bias. When we get to bias, I'll tell you, you know, a lot of this stuff, I just keep writing it down with every new amp that I get. Fun thing about this one, we had a good set of channels over here, so I'm going to either be able to get a bias current from this side that was good, or a bias voltage, or maybe both. Sometimes it's hard, and I'll explain that later. But to know what to set these over here to. Sometimes you can find schematics. Sometimes you can find posts and forums where somebody asks, you know, that they've repaired one and they need to know what the bias setting is, and a tech will reply and tell them what the bias setting is and whether to set it by current or voltage on the emitters, resistors or whatever. And so, but when you have one set over here or a channel in your amplifier working, you can get the readings to set your bias. And I write all that stuff down. I got three notebooks. I'm sorry, I'm not paying attention to where this camera keeps getting knocked to. I've got 3 notebooks I've been filling with just information like that that's not necessarily available. So let's see, we did the RCA repairs. We have done checked the transistors and the resistors, replaced those 2. We do need to deoxit these, but I'm going to save that. We've got just enough time to go on ahead. I believe this is the right way, if I'm not mistaken. Yep. Actually, we're right past 30 minutes. So here's what's going to happen is I'm going to go ahead and off camera, I try to do the stupid boring stuff off camera, bolt this thing down so that we're ready to solder a leg on here and get this all level and make this nice, and then we'll be able to take it out. As a matter of fact, if I explain it now, you know, you put bolts back in the strip to hold it flat to the heat sink. You put the bolts back in the board so it's in the correct position, and that sets the height of where this sucker goes. If I can show you that, I can grab a hold of this and see how this flops up and down. Oh, you can't see it, my hand's in the way. See how this flops up and down? It's floating right now because I don't have all these in. Well, once that's screwed down correctly into place, and this is screwed down correctly into place, I can put a tack solder on all those, and that'll hold this in the right position in relation to that board, and then I can go take it back out, turn it over, and solder it all up. So I'll probably bolt it down, do that tack, unbolt it, and bring it back down here to start the next video, so that we've set this height correctly, and that way we can move on to bending up these biased transistors right, getting the thermal paste in. I did, while off camera, clean this heatsink up pretty good, and so we can get to mounting this thing on and get to get jamming to get this thing finished and give it a test and see if we are right, if I am right that these survived and we just need to replace those 2 little drive resistors. Thanks for watching. Please comment. Comments are awesome. Love a bunch of comments. Hit like if you want to. Subscribe if you'd like to see more of this, or if you learned something from it or anything like that. I always appreciate it. Love the interaction. Like I said, comments are really fun. We'll have more of this kind of stuff. We'll have more of all kinds of stuff, and I'll do other electronics when I come to them. Most of the stuff I've had here lately have just been super simple repairs for some of the common household electronic stuff that wasn't even 2 seconds. I soldered some broken wires and soldered in a USB port for a PlayStation controller. So, but we'll try to get some other fun electronics in here, or fix a phone charging jack or something like that along the way. And like I said, I thank you again, and thanks for watching, and be good.